Hello everyone. Today we are going to solve this probability question and look at a few different ways of solving this question, and we are going to look at some of the common mistakes people make when solving this question. And my goal here is to help you understand that the same question can be solved in different ways. As long as you have your strategy right about counting, the problem can be solved with different strategies. You will get the same answer. However, if you make a mistake around the strategy, then you would run into a problem. So let's look at some of the common mistakes and the wrong method to solve this problem. So one common mistake in solving this question is not paying attention to this without repetition word. If you don't understand this or ignore it while reading the question, you end up considering 4-digit numbers such as 3333, which is not allowed. The question only states that you could use each digit once. So that is one mistake. It's a silly mistake, and only you can help yourself not make this one. For some of the other mistakes people make is looking at the question and really figuring out which numbers they have to consider as greater than 3800. So this is given, 3800 is given, and what people end up doing is, what is greater than 3800? Somewhere 39 and two numbers, and any numbers with 5, right? Any numbers with 7, 8 and 9. In this case, the mistake you are making is actually any number that has 3, 8 and two other digits. Since none of the digits are actually 0, 0, you would get a number greater than 3800. If you miss this, then you will get an answer that will not be correct, and very likely this mistake would be baked into one of the answer choices. You would look at the answer choice, your eyes will light up, and you will mark the incorrect answer choice even though your method was actually correct. You might end up making this mistake if you are hurried for time of not considering the 38 one. So that was a short discussion on the wrong method and the common mistakes. Now I'm going to go into the right ways to solve this question in many different ways. Okay, so right methods to solve this problem. Before we dive into that, let's just quickly read through what the question has given us and what we have to find. We are given that there is a bag which has chips that have 4-digit numbers engraved in them, and those 4-digit numbers consist of these digits only without any repetition, and we are asked to find the probability that when we pick the chip out of the bag, the probability of getting that chip, the probability of number on that chip would be greater than 3800. So first, let's think about probability. Probability is simply favorable outcomes divided by total outcomes. So in terms of our strategy, we have to find number of ways to get something greater than 3800, and we will remember to include the numbers starting with 38, otherwise we will get this wrong, divided by total number of ways of making 4-digit numbers from the given digits. So how would we go about solving this question? 3 different methods to solve this question. In our first method, we are going to talk about strategies to calculate the total number of ways of making 4-digit numbers. That would be our first step 1, and in step 2 we will find 3 different ways of actually calculating 3800, and then all we have to do is divide. I hope you understand you don't have to use all of these 3 methods in GMAT, but it is important to understand you can do it in so many different ways. Which method you end up choosing will depend on how familiar you are with the method, how much you have practiced, and which method you prefer. So let's get started. First, we are going to find the denominator of that probability formula, which is basically total number of ways of making 4-digit numbers, and we are going to do it in 3 different ways. The first way is direct permutation, which is, we know that arrangement is important. We know the digits cannot be repeated, so we can simply take 6 digits, and since arrangement is important and we are creating a 4-digit number, we say we need to pick and arrange 4 digits out of the 6 digits, and that will be our number, which will be equal to 360. The other way to think about is, let's say we have 4 places and we have to fill these 4 places with 6 of these numbers. The first place can obviously be filled in 6 ways because I can pick any of these numbers in. The next, I can only take 5 of the remaining digits because I've already used one of digits. So next would be 5, the next would be 4 and 3. Since we are using a counting method, we are going to multiply because first can be done by 6 and the next could be done by 5 and the next could be done by 4 and number of 3. So it's not an OR problem. So we have to multiply the number of ways, and as you would see, this would also lead to 360 ways. And finally, you can do it in one another way. You can select some numbers from the 6 numbers and then arrange them. So selections are done in 6C4 ways. And then since there are 4 numbers, you can multiply by 4 factorial ways to actually arrange them in 4 factorial ways. And this would actually be same as 6p4. So this was slightly easy. The 3 different ways were slightly easy. Now when we actually find the numerator, you would find that there are different ways, and I will take 3 of them to solve for the numerator. Let's go there. So here we are going to find the total number of 4-digit numbers which are greater than 3800 formed by these digits, and we are going to make sure that we include 38 in our calculation. So how many ways can we find it? Let's say my first digit is 5 and I haven't filled out the rest of the 4-digit number. Since I've taken 5 already, that cannot be repeated. I have 5 digits left. I can fill them in 5 ways, which means that is 60 ways. One thing that you would notice is that exact same thing would apply to 7, 8 and 9. So for all of these, I would have 60 ways of doing exactly that. And I have a plus sign here instead of a multiplication sign. Why? The reason I have a plus sign is because the numbers that start with 5 cannot have numbers starting with 7. So they are 2 different mutually exclusive cases, and hence I do not multiply them because they cannot happen at the same time. Another thing that we would now do is add all the numbers that start with 38. So here I have fixed the first 2 numbers and I have 2 other numbers available from the 4 numbers. So this will be 12 ways, and similarly 39 would also be 12 ways. So that is plus 24, and this gives us a 264 as the possibility. Similarly, we can go the other route. We can take the total 4-digit numbers, which is 360, minus all the numbers starting with 1. Now, I don't really need to do the calculation. When I take any number as a starting point, I can create 60 arrangements for that. So that would be 60 minus any number that is starting with 31. I already saw that any numbers that I start with 38 would have 12 possible arrangements or 12 possible numbers. It will be the same as 31 because all we are doing is fixing the first 2 digits and having 4 ways to calculate the 3rd digit and then 3 ways to calculate the 4th digit. So that will be minus 12 plus another 12 for 35 and another 12 for 37, and this will also result in 264. And finally, we look at this fractions approach, which is more of a quantitative reasoning approach. We already saw that number of arrangements starting with any digit is about 60, right? We saw that for 5 it is 60. If we started the number with 7, it is 60. So it is going to be 60 numbers per digit, right? And that comes down to 360 as our total possibility. Now we know that to calculate numbers greater than 3800, let's assume these 4 are part of our set already. We also know that for any single number, there are 5 possibilities of the 100th digit. So for example, for 3, the possibilities are 1, 5, 7, 8, 9. And each digit would have, since there are 5 different possibilities, each digit would have an arrangement of 12 possible, right? And since I need to take only 2 of those, which are 8 and 9, I will take 2 of those and I will take these, and instead of calculating them individually, I would just say that since this is 4 of This is 4 of all the numbers. So for all the numbers, the number of ways was 360. Since all the numbers were 360, the 4-digit numbers represented by numbers greater than or equal to 5 as the thousandth digit, or 5000, would be 4 divided by 6 multiplied by 360. And I'll add the number of ways of getting 3800 and over by saying that numbers greater than 3800 would be represented by either the number starting with 38 or 39, which is 2 out of the 5 possibilities of getting a 60 way from starting of, which gives me 240 plus 24 equals 264. So I did not have to do all of this calculation. If I had understood how the number of ways are actually divided, I could have just calculated with the help of fractions, is what I'm trying to say here. So each of these methods gives you 264, and finally we need to solve this question. Probability would be 264 ways of finding numbers that are greater than 3800 divided by total possible numbers, and that would result in 11 by 15, B as your answer to the question. I hope you found this solution helpful. I hope you understand there are so many different ways of solving questions which involve permutations and combinations. It totally depends on what you feel comfortable with and how you apply it. You have to be very, very meticulous and careful about applying the questions. Otherwise, you may end up making mistakes if you forget, including some certain cases. In the next questions, we will see more involved concept. If you found this video helpful, please don't forget to like. If you have any questions or doubts from this approach, please leave a comment. I personally respond to all the comments. Thank you very much. All the best with your prep.